Welcome to ViewChem, the Chemistry Animations channel. Petroleum, origin, extraction, and refining. Petroleum is also called as crude oil or mineral oil. It is formed due to the decomposition of dead marine animals by the action of anaerobic bacteria. The word petroleum is derived from Greek and Latin. Petra, in Greek, means rock, and oleum, in Latin, means oil. So, petroleum means rock oil. It is called so, as it occurs beneath the surface of the earth, below the impervious rocks. Petroleum is, usually, dark yellow, or brown, or green-colored, oily liquid, and is lighter than water. Petroleum is a complex mixture of various hydrocarbons. It contains alkanes, cyclooctanes, aromatic hydrocarbons, and other compounds of oxygen, sulfur, and nitrogen. Depending on the source, the composition of petroleum may vary. Origin of petroleum. According to carbide theory, petroleum is originated from inorganic compounds. Coal deposits in the earth crust would have reacted with hot molten metals to form metal carbides. So formed carbides, on hydrolysis, produced hydrocarbons. Support for this theory can be obtained by the production of petroleum-like liquid by the hydrolysis of uranium carbide at high temperature and pressure. But this theory fails to explain about the presence of compounds of nitrogen, sulfur, chlorophyll, and hemin. According to Engler's theory, that is, organic theory, the Dead Sea animals were buried under the deeper parts of the earth due to several reasons. Subsequently, these have undergone decay, and then decomposed to form petroleum. Engler was able to demonstrate the formation of petroleum-like liquid by the decomposition of fish oil and animal fat at high temperature and pressure. Though this theory can explain the presence of compounds of nitrogen and sulfur, but cannot account for the presence of chlorophyll in the petroleum. According to modern theory, petroleum is formed by decay and decomposition of both plants and animals by radioactive elements or bacteria at high temperature and pressure. This theory can explain the presence of compounds of nitrogen and sulfur, and also presence of chlorophyll and hemin in petroleum. Classification of petroleum. Petroleum can be classified into three types. The first one is paraffinic base, crude oil. It contains higher molecular weight paraffins, which exist as solids at room temperature. It produces high-grade lubricating oils. The second type of petroleum is asphaltic base, crude oil. In this variety, large amounts of asphaltic matter, that is, aromatic matter is present. This variety yields lubricating oils that are more sensitive to temperature changes than the paraffin-based crude oils. The third category of petroleum is mixed base, crude oil. As the name indicates, that this type of crude oil contains both paraffinic and asphaltic content. Most crude oils belong to this category. Extraction of petroleum. Petroleum exists in the deeper parts of the earth crust, below the impervious rocks. So, to mine the petroleum, a setup consisting of two concentric pipes, are drilled into the deeper parts of the earth through the impervious rock. Then, hot air is blown through the outer pipe. As a consequence, the crude oil comes out through the inner pipe. Natural gas is also present, along with the petroleum. Earth crust. Shale is a type of sedimentary rock, originated from the mud, consisting of mixture of minerals of clay and others. Rocky layer. Petroleum. Natural gas. Rocky layer. Water. Outer tube. Inner tube. Tube to extract natural gas. Hot compressed air. Petroleum coming out. Natural gas coming out. The simultaneous extraction of petroleum and natural gas can be viewed as follows. Refining of petroleum. Refining of petroleum is a very important commercial aspect regarding the utilization of petroleum. The crude oil, after mining, is thoroughly washed to remove salts. This process is called as desalting. In the next step, the crude oil is washed with acid, followed by alkali, to remove alkaline and acidic impurities, followed by washing with water. The process of separation of various components of crude oil by fractional distillation is called refining of petroleum. In this process, unwanted impurities are distilled off, and the useful fractions will be collected. Refining of petroleum is carried out in the following stages. Stage 1. In this stage, water is removed from the crude oil by Cottrell's process. Crude oil is an emulsion of water and oil. To remove water, the crude oil is allowed to flow between highly charged electrodes. In the process, water molecules accumulate to form large drops, and then separated from oil. Electrostatic precipitator, fitted with electrodes. Crude petroleum, containing tiny water droplets, is allowed to pass into the electrostatic precipitator. In the electric field, tiny water droplets coalesce to form bigger water drops, and then settle down. In the later stage, water is removed. Stage 2. In this stage, harmful sulfur compounds are removed by adding copper oxide to crude oil. Then, the precipitated copper sulfide is filtered and removed. Stage 3. This is a very important stage, wherein the fractional distillation of crude petroleum takes place. The crude oil is heated to 400 degrees centigrade in an iron retort. Then, all the volatile components are evaporated. These hot vapors enter into Fractionating Tower, which is a large column containing several horizontal steel trays to collect the fractions. Each tray is equipped with a small chimney with a loosely fit cap to allow the passage of uncondensed vapor. Higher boiling fractions will condense at the bottom, and the lower boiling fractions condense at the top. As we observe the trend of condensation from the bottom to top, the boiling points of the fractions decrease. Furnace to heat crude oil. Fractionating tower. Entry of crude oil, heating the furnace to 400 degrees centigrade. Vaporization of crude oil. In the fractionating tower, at the bottom, the temperature will be high. When we observe upwards, the temperature decreases. Now, let us observe the process in a stepwise manner. Fractions, having very high boiling points, will condense as residual liquid. High boiling point fraction condenses first. In the next step, fraction, with relatively less boiling point, condenses. In this manner, condensation of fractions, in accordance with their boiling points, take place. Finally, fractions with very low boiling points will go out as uncondensed gases. We can view the processes simultaneously. Data on the important fractions obtained after refining of petroleum. The lightest fraction contains lower alkanes with 1 to 4 carbon atoms. These are uncondensed gases like petroleum gas or fuel gas or LPG. The boiling points of these fractions will be less than 30 degrees centigrade. These fractions will be useful for heating, cooking, making plastics, and to prepare LPG. The other lighter fraction contains 5 to 7 carbon atoms. It is petroleum ether. The boiling range of this fraction would be 30 to 60 degrees centigrade. This fraction will be useful as solvent. Another fraction, heavier than petroleum ether, contains 6 to 9 carbon atoms. It is gasoline. Its boiling point would be in the range of 70 to 120 degrees centigrade. This fraction will be useful as automobile fuel and dry cleaning agent. Relatively more heavier fraction than gasoline contains 9 to 13 carbon atoms. It is naphtha. Its boiling point would be in the range of 120 to 200 degrees centigrade. Naphtha is useful as fuel and a valuable source for many organic molecules. It can be cracked to make petrol and other hydrocarbons. Kerosene oil is the next higher boiling fraction. It contains 11 to 16 carbon atoms per molecule. Its boiling range would be 200 to 260 degrees centigrade. It can be used as a fuel, illuminant, and starting material for making other products. The next higher fraction contains 16 to 18 carbon atoms per molecule. It is diesel oil. Its boiling range would be 270 to 330 degrees centigrade. It is mainly used as an automobile fuel. Heavy oil, the next higher fraction, contains 17 to 30 carbon atoms per molecule. Its boiling range would be 340 to 400 degrees centigrade. Heavy oil can be used as fuel for heavy diesel engines, in metallurgical furnaces, in the preparation of lubricants, cosmetics, medicines, semi-solid lubricants, candles, and shoe polishes. It can convert it to gasoline by cracking. Finally, the leftover residue contains asphalt or petroleum coke. The number of carbon atoms per molecule will be above 30. The boiling range of this fraction will be above 400 degrees centigrade. It is useful as waterproof fuel and for laying the roads. Thanks for watching. Please like, subscribe and share.